Alright, this is a circuit emulating the sensors for when the window is fully open or fully shut. This is a push button switch. This is an LED. You won't use it in the actual window, but it's useful here. And this is a resistor. You will need to use that. I'll explain why in a minute. But what this is basically this circuit. Because there's an output signal, which is a voltage from one of the pins in the Raspberry Pi that's traveling through this wire, and this node is this node right here, and this diode is this diode, and the diode is basically like a short, so it doesn't contribute very much to the overall circuit as far as resistance. And then this is a switch which can be either open or shut, meaning this push button switch right here. Right now it's open, but when you push on it, it becomes a short circuit. So it's leading some current through the resistor. Now this resistor is necessary because otherwise it will fry the Raspberry Pi. That's why you need it. The other reason you need it is because you want a live signal that's on when the buttons, when the circuit's open. I mean on when it's a short circuit, button down, and off when it's a open circuit. In other words, the same live signal as the light. In other words, whether it's true or false depends on whether or not there's current traveling in the circuit. Now, a light signal is a voltage. So this resistor, because this is basically a short, this is basically a short. So this resistor is pretty much most of the voltage. I mean, most of the resistance, so it has most of the voltage. So it's pretty much the same logic signal. So it works. Now, first thing you must know is have the resistor. But now you know that. The other thing you have to know is that if you look at this push button switch, you'll notice these two pins. See, it has one pin that's closer to the top of the circuit, and it has one pin that's closer to the ground, and that corresponds to this node right here and this node right here. And it's very important that the input pin, this one's the input pin, this one reads the live signal here. It's very important that this one is connected at this node and not this node. At this one, the leg closer to the ground, the pin closer to the ground. Like in here, this is the voltage that gets sensed. And the idea is that there's always some voltage up here. You just keep it like that, but it depends what it senses. Depends on what the button's doing. Okay, so I have some code right here that I brought next to it. So this is a flash object. A flash object is what's called a virtual device to output some signals. It outputs a logic high signal, a logic 1 signal, from this pin, which is pin number 37 on the board. And then an I object just senses whatever's at that pin, basically. And since we're sensing at pin number 38, the yellow wire, that's what it's connected to, the I object has that pin 38 in it. And so now I'm gonna make the I read the signals. Alright. Alright, right now it says 0 because the light is off. Okay? So now I'm gonna press the thing down, and I'm gonna put the phone down and type that again. Okay, so I made it read again, and then I asked it what the signals in it were, and it said logic 1 because look, because my finger's on the button, it's glowing. It's a logic 1 signal. Whenever this dial is glowing, this signal is a logic high. Whenever it's not, it's a logic low. Which means whenever this button is pushed, it's a logic high. Whenever it's not, it's a logic low. So that logic signal is how our system's gonna know when it's closed, when it's all the way closed, and know when it's all the way open. Because you will have to install a button on one end, the end where it's closed, and on the other end, the end where it's all the way open. You'll need 2 buttons and 2 resistors to keep from frying, and you won't need the diodes. That's just for demonstration purposes. It'll just be a wire. You'll basically just do this. You feed it to this leg, I believe. But yeah, that's enough explanation for now.